Hello and welcome to another STEM in a Box instructional video. Today what we'll be looking at is some classroom tips for project-based learning using Scratch2 offline. Now what we'll be covering today is a basic list of tips that help deliver project-based learning. So the first thing is to set clear tasks, to provide some exemplars. You need to scaffold appropriately, obviously, especially for differentiated learners. We need to get the kids to think algorithmically or step by step, break that problem down for them, and that's basically creating an algorithm. It's useful to use the small stage layout to focus on the code when you need to so they can see it better. You will need to get them to learn the stage coordinate geometry system because that underpins all of the movements. Using comments is extremely useful and important. Both for you and the students, and creating template files to give to the students is a very good idea, as is collecting assessment via them submitting the files themselves, because they can put lots of annotations and codes and explanations. Everything that you really need to assess can be put into the Scratch file itself. Okay, so let's get started. So what task would I like to set? Well, I'm thinking a really basic maths problem. Let's say we're doing area in maths, and I just simply want them to draw a rectangle. So Scratch doesn't have units as such like centimeters or millimeters, it's just steps, that's it. Okay, so first thing I'm going to do is use the right click, add comment, and I'm going to use this to write a task sheet. So the task is going to be rectangular area. Excellent. So I could save this as a template file. I'm going to save it as a rectangular area task. And so that means you could put that on your common network drive, and then it's pretty obvious really. The students can then open that, and it's got the task sheet in there already. Okay, great. So that's just what we did before. All right, so now all the students got this in front of them when you're up to that. Okay, so now I'm going to run through an example. So this could be direct instruction of how we're going to do this. So the first thing is that I'm going to use the 100 by 100 steps. It's asking me to get the grid backdrop, so I'm going to select on the backdrops there and go and get the grid, the XY grid. It's the very last one, just there. Excellent. So you can see here that the X coordinates negative 240 to positive 240. It's left to right, and then up and down, negative 180 to positive 180. So the origin is at the middle, which is 0, 0. So that's just standard Cartesian geometry with your 4 quadrants. You don't want to use negative numbers, that's fine. Then you can make sure that you set the task as I will be, so that they're working in the positive quadrant up here, where X and Y remains positive. For extension kids, or an extension task, you could say, I want you to work in the negative quadrant. I want you to work in this quadrant down here, or something like that. So that adds a level of difficulty, which you could set as an extension to this same task. Okay, so that's check one. We've got the XY grid. Now let's do 100 by 100. So I'm going to start my algorithm. First thing is I'm going to shrink the sprite a little bit because it's a little bit too big. So just going to shrink it like that. Now the first thing is I'm going to put the sprite at the origin, which is x and y equals 0. Okay, so what you can see is that when I do a code snippet, if I click on that code snippet, it will actually execute that code. So that's why the sprite is moving back to the origin. So that's the first thing. Now step 2 is put the pen down. So I'm going to put the pen down. So the pen is now down. So now it's just some moves. So go back to motion. So you could use, if you wanted it to jump straight away, you could use move. You could use change by, or you could use glide. I'm going to use glide because there's an educational reason, because you're putting both the x and the y coordinate in both at the same time. It helps kids keep an idea of what both coordinates are every time, whereas when you use the move and the change, they have to keep that in their head, so it's like one step removed, so it's a little bit more concrete. Okay, so we want to go straight up, which will be y100. Now we might also put a bit of a delay in there so that it doesn't, when it gets to each corner, it just waits at each corner. So if you go into control, I'm just going to wait 1 second. Now you can do a really handy shortcut here. You can right click and duplicate, and what that's going to do is it duplicates any code that is underneath, well, from where your mouse cursor is underneath. It'll duplicate that, and then you left click and snap it in. Okay, so we're just going to change these coordinates. So now we want to then go right, so we're going to go to x equals 100, y 100. So I'm going to duplicate that again. So now we're going to go down. So going down will be, x will be going from 100 to 0, so we're going to change that. So now we're in the bottom right hand corner of the square, and now we want to go back to the origin, so that's easy. Okay, so, and then after that we want to put the pen up. Okay, so we go to pen, and then we go pen up. All right, so let's just try that code. So if I click on it, oh no, I've made a mistake. Okay, great. So now what we're doing is evaluating. I've made a mistake. I'm testing my code. I've made a mistake. So it didn't go down. So that was it got to the second coordinate. So, and, oh, I see. Yes. So x needed to stay 100 there, and y needed to go to 0. My mistake. And the other thing is the line's really thin, so I'm not happy with that. So what I'm going to do is I'm going to change the look of the line. So I'm going to set the color to maybe pink so that I can see it a little bit better. I'm just going to snap it inside there. And I'm also going to change the pen size. And I'm going to make it much thicker. I'm going to make it 5. So let's test that code snippet now. Okay, that looks better. Alrighty. Now maybe at the end of that, what I need to do is, I don't need to do anything. So that's basically what I asked them to do. Now, if I want to put that in a loop, I don't have to put in a loop, but if I want to go and put it in a, so that it starts when I press the green button there, the flag, then that's what I can do. Now what I'm going to have to do at the end is also see how the pink triangle, the pink rectangle is still there. I'm going to have to erase that. So if I go into pen and then just clear it, I might wait a couple of seconds. All right, I might wait 3 seconds, and then I'm going to clear it. Oh no, I think what would be best would be, yeah, I'm just going to clear it. Okay, let's try that. So what would be better would be to clear it in the beginning, wouldn't it? Okay, so I'm going to put it up there. So let's try that now. So you see how it's cleared in the beginning? So using trial and error and evaluation is important. Great, so that looks good. So that's essentially the C-level response. That's just exactly what I asked them to do. So another option might be any two numbers that multiply together to give 10,000 will be sufficient. Now, the other thing that they could do is annotate the algorithm in the animation itself. So how would I do that? Well, if we say start at the beginning, here when you go to the origin, then we're just going to get the cat to say what's going on. So if we go to looks, then I'm going to now I'm not going to need the wait because when I say something it's going to take that time. So I'm going to say now at origin. Okay, so let's see what that looks like. I made a mistake. It's not at the origin at all. I just put it in the wrong place. So I'm going to click that. So when I'm clicking it, when it's glowy, the code is executing. So I just click it again, it doesn't go glowy. So I just need to move that here like that, and I need to pop it before the glide command. Okay, so let's check that again now. Now at the origin, yes, great. Excellent. So all we need to do now is we can just use the say command instead of the wait command all the way through. Okay, so that's going to be that, and that's going to be in there. Oh, looks like I've made a mistake again. All right, I need to put that one in there. Good. So all we're going to do is put the coordinates. I'm going to get rid of now at. I'm just going to go coordinates. This is the typical way to represent coordinates, would be brackets and then x comma y. So that's going to be x 0 and then comma 100. Okay. And that's going to be 100, 100. And that's going to be 100 and 0 for y. And now this one's going to be, I'm just going to say back at the origin. And then after that I might say, I can duplicate that. After that I might say $10,000 steps square okay. We don't need the wait 3 at the end now. Okay, so let's try that. Okay, great. So that's basically the task sheet done. I've basically illustrated a C-level response and a higher level B or A response, by the C-level being just where they've written the algorithm step by step there as notes only. A B-level response and above might be where they've also, in addition to that, have put it in the animation itself. Okay, now the other way that is very useful, well, not very useful, important to get them, is to put the annotations directly attached to the code blocks itself and their thinking. Okay, so I go right click here and then add comment. So why do I have the clear there? Okay, so that's to remove previous pen. Okay, now this little triangle here is really helpful because it sort of shrinks it up there and then sticks it into there. So now what I'm going to do is right click here and go move to origin. Okay, so pen down is here. I'm going to start draw, thick line, okay, and oh no, I didn't want that. I'm going to add comment, and that's going to be move up 100. And so what you don't want to allow is them to use the same English words in their annotation or their comments, so as is in the block, because it's a method for checking that they understand. So having them to paraphrase what the block is. So yes, the block says glide 1 second to x 0, y 100. So they can't just write that in the annotation because that doesn't indicate that they understand anything. So they need to use different language. So that's why I'm illustrating here. Move up 100 is exactly the same. That's what the glide 1 second to x 0, y 100 does, but it's in different language so that I know that they understand. Okay, so likewise here, that's going to be move right 100, and then this one's going to be move down 100, and then this one is going to be move left 100, and then you're back at origin now. Okay, so the annotations and explanations are basically how you can assess whether they understand what's going on, and you can see that they are getting the reasoning. Okay, and you can say that, look, if you've got those extra, so there's 3 ways to write the algorithm and explain what's going on, and that's how you're going to be getting the B's and the C's, is that you can demonstrate your understanding. So in high school we call that, most subjects it's called analytical thinking and communication. Okay, great. So the students could actually hand this in, so they simply save it and put their name on it. So it might be, Johnny B, rectangular task, and then they can save that to the common drive in a folder that you've created, and then you can sit down and quickly mark those, and you've got evidence, you've got a copy of the evidence. That can be printed out easily as well if you really need to, but most of the time you don't need to. You've got the evidence there sitting in the folder, and it's easy to mark. Great, thanks so much for watching.